once again. So, real quick study tip, remember to stop studying at least 2 hours before your exam. I suggest you stop the entire day of your exam. You should not try to cram more information in, especially if it's information you've already looked at. You want to keep it in your long-term memory. Don't confuse your brain with putting it back into your short-term memory, okay? This is very similar to like if you were running a marathon, you're not going to go run, a miniature marathon right before you go run your big marathon, right? So rest your brain, feed it, make sure you're eating healthy, you're getting plenty of rest, and then you're breathing deeply, relaxing, and thinking positively before you take your exams. Um, Now, I am actually going to post a document later this week on additional tips for our new format, our online exams. So look out for that and look that over. All right, so let's get into flow. Okay, so chapter 14, cardiac output, blood flow, and blood pressure. Please ignore that previous slide. I forgot to delete it. And I think I forgot to delete it in the slides that I posted as well. So that's not applicable. That was from last semester. Okay, so part one, we'll actually do this into a bunch of short segments. Okay, so cardiac output equals heart rate times stroke volume. Remember, we put that on the board way back in the beginning of the semester, and we talked about why athletes have a larger stroke volume, or I'm sorry, they have a lower heart rate because they have a higher stroke volume. So we'll be talking all about that stuff today. Okay. So when we're talking about cardiac output, we're talking about all the blood that circulates through your body in 1 minute. And that is 5 to 6 liters of blood. So your heart pumps through 5 to 6 liters every minute. And that makes sense when you think about each individual heartbeat. And you have about, 60 to 80 heartbeats per minute. So it adds up. Okay, so heart rate is beats per minute. And remember, we talked about two heart sounds, the lub and the dub. So one heartbeat is lub dub, and then another heartbeat, lub dub, right? So two heart sounds per heartbeat. Okay, and so stroke volume is milliliters, right? Much smaller, but then you do that over and over and over again, many, many times per minute. That'll add up to your liters, your cardiac output. Okay. All right. So to calculate your stroke volume, you're going to take the end diastolic volume and you're going to subtract the end systolic volume. Why is that? It's because you don't push all the blood out of your ventricle with each beat. You still have blood in there. So end diastolic volume is all of the blood when the ventricle is full, how much blood is in there, and that's about 135 on average at rest. Okay, and then your end systolic volume is the blood that is still there after you've had your contraction, right? And so that's about 65 mils. And so then when you subtract that, it means you actually pushed out of the heart, you pushed out 70 mils with that one heartbeat. Okay, so this is the amount of blood pumped with each heartbeat, on average 70 mils. And then if you multiply that times your heart rate, you will have your cardiac output, 5 to 6 liters. Okay, now the body's going to change all these values constantly. Every time you move, when you're asleep, when you're exercising, right? Everything you do, even just being stressed out, right? Not even necessarily moving around, but everything you do will affect your heart rate and will affect your cardiac output. Okay. What else did I want to tell you? That's it for this slide. Okay. So we are going to be studying this equation, right? The cardiac output equals your heart rate. Here, your book calls it cardiac rate, same thing, right? Heart rate times stroke volume. And we'll focus on this part first. So, what factors influence your heart rate or cardiac rate? You'll see sympathetic nerves and parasympathetic nerves both influence your cardiac rate. And notice this is a dotted line. So the dotted line is a negative effect, so it's going to slow down the heart rate. And the sympathetic is a solid line, so it's going to speed up your heart rate. Then we'll look at the rest of this afterwards. Okay. So the effect of the autonomic, parasympathetic plus sympathetic equal autonomic, right? So the effect of the autonomic nerves on the SA or sinoatrial node, okay? And you've seen this before, this picture on top. You saw this before when you talked about pacemaker potentials. So remember we said there's a slow depolarization and it's automatic. It just keeps happening without any outside stimulus, right? And that's the HCN channels, right? So that is the focus of how you speed up or slow down the heart rate, is how long it takes to reach threshold. The action potential itself, the yellow portion, it never changes. It's always going to be the same height and it's always going to take the same amount of time. Okay, so the yellow part does not change. The yellow part is the actual action potential. Okay, so now let's look. Sympathetic nerve. Okay, the sympathetic nerve, as you already know, is your fight or flight, right? It's going to speed up your heart rate. How does it do that? It does that by making it easier to reach threshold. Therefore, it does not take as much time to reach threshold, and you're going to have more action potentials in a given amount of time, right? So this is the same amount of time here as it is here. And notice here you have 1, 2, 3. And these 3 action potentials are going to lead to 3 heartbeats, right? And in that same amount of time, when the parasympathetic nerve is more active or dominant, you're going to see it takes a lot longer to reach threshold, and you only get the 1. In this example, you only get 1 action potential in the same amount of time as 3 when it was the sympathetic, right? So this shows you that the sympathetic nerves speed up heart rate by decreasing the amount of time it takes to reach threshold. And on the flip side, the parasympathetic nerve, when it's in control or when it's dominant, it's going to make it take much longer to reach threshold. So that depolarization is going to take much longer in the SA node before you get your action potential. Okay. So both parasympathetic and sympathetic nervous system, which together are the autonomic nervous system, they both innervate the SA or sinoatrial node. When the sympathetic nervous system is dominant, it's going to speed up the heart rate only by changing the depolarization time to reach threshold. The action potential itself does not change. All right, so I repeated that many times. I'm sure you've got it. So how does it do that? So when the sympathetic nervous system is activated or dominant, it's going to release norepinephrine, and that is what's going to change the threshold, the ability to reach threshold, and so it'll be easier to reach threshold, and the pacemaker will then be faster, right? And then parasympathetic, when it's dominant, is going to release acetylcholine, and that's going to make it take longer to reach threshold. You're going to have fewer action potentials, right? So good. I'm going to stop here, and then we'll do another segment. Okay.